Assalamu alaikum again. This is the second part of the lecture number 2. We talk about Caesar cipher in the first one, which is one of the substitution cipher. Now we'll talk about Vigenere cipher, which is another sample or another example of substitution cipher. Vigenere cipher is more advanced form of Caesar cipher. So basically, I'll just go to that. It put the letters into a matrix. So this is the letter A, B, C, D, E, F, and it put it in a matrix. The matrix will be 26 by 26. Why 26 by 26? Because we have 26 letters in English. All right. So what does that letters? How they put the letters? This is how they put the letter. The first one is 0 shift, the same order. Second one with 1 shift. Third one with 3 shift, and fourth one with 5 shift, and so on. So this is not counted. Okay, you just start from here. The start is A, B, C, and so on, and to the last one. All right, and the last one we have 26 shift, and the letter start with Z. All right, we can do only maximum of 26 shift. That's the only we can do. All right, now you use this letter to map it to another one. So if I have we have two types actually. This is the show the shift. This is the number of the shift, 1 2 3 4 5 until 25. Sorry, until 25 shift. All right, because we have already here 0 shift. All right, so we have 26 row exactly. So let's take an example. We have two types, either without key or with keywords. Okay, so if I want to encrypt the word security without a keyword, this is the simplest way, and we have the sophisticated way. Two part, either you can use a keyword or you can do the encryption without keyword. So let's take the word, for example, security. I'm going to take the word security. All right, this is I'm gonna write it here, security, SECURITY. So let's take the first one. So one letter, first letter, second letter, third letter, fourth letter, fifth letter, 6, 7, and Y is 8. So the order of the letter means the number of the shift. So S is letter number 1. We take it from row shift number 1. Where is S? This is S. All right. So S will be taken from what? From the shift 1. All right. So this is S. All right. Let's come up to S here. Where is S? Where's shift number 1? This is shift number 1. Sorry. So let me just write it here again. S E SIC U RE T. So this is number 1, 2, 3, 4, 5, 6, 7, and 8. We said S in the shift order number 1, so it mapped to T because this is shift number 1. Alright, so the cross between them is T, so S become T. And the E in number 2, we take row number 2. This is the E, we take row number 2, which is basically G, right? And so on, right? And we take C as number 3, so we take row number 3, which is F basically, and U number 4, this is U, we take number 4, which is basically become what? This is number 4. Just a long way to the row. Yes, so it's become Y, and R become what? Look at the R here with number 5. It's become W because this is row number 5. It's become W. The I is row number 6, so it's become O as you map it to number 6. Alright, and T will be taken to row number 7. This is T, will be mapped to row number 7. This is row number 7. To make sure, just look at the row, and you can use any kind of things to hide the row. So it's become what? A. And the last letter is Y. This is Y. We take to the 8th row, because the I in the last number 8, digit number 8, or position number 8, it's become G. So G security is encrypted to T, G, F, Y, W, and so on. T, G, F, Y, W, G, A, what's the last one? G. Yes. So this is the very simple way of using what? Using Vigenere Cipher. But the other one, we can use what? We can use the keyword. All right. So let's start again. All right. Now, if you want to use a keyword, that's a different thing. All right. Now, the keyword, I'm gonna go back and let's leave this for example for you. Let's work on this matrix, for example. All right. So what's the word we're gonna encrypt? It is security. The word is what? Security. All right. And the key, we're gonna use every. So the key is every. Now, because the key is shorter than security, the plain text, we have to repeat it. This is why we repeated every first time and we wrote it twice, so the length will be matched. So the keyword should have the same length as the plain text. All right. So let's let's encrypt it. Okay. Using this, I'm gonna write it right here. Okay. Let's say S E sec U re T. Okay, what's the key? The key is mapped to the letters. Okay, you map the key to the letters. You can write it on top or here. So the key is every. A B R I, and then it's short, so I can repeat it again. I B R I. Okay. All right. Let's work on it. Now let's take the S. Okay. Let's map the S with the I. Where is the I? Here. Okay. So the intersection between S and I is become what? A. Okay. Let's take E and what? B. This is the E with the B. It's become what? The intersection is F. Let's take the R. Okay. Where are we gonna map the R with what? With the sorry, take the C. Sorry, C. We're gonna map the C with the R. Alright, where's the R? The R is down right here. So the C become what? T. Let's take the U. Okay, where's the U? Okay, I think, yeah, that's fine. Where's the U? U is here. So the U is mapped with the I. Where's the I? Is here. Okay. U is mapped with the I. It's become C. As you can see here, this is the full encryption. So A, F, T, C, and then the R will become Z. Let's check the R, the last one. So the R with the I as well. Where is the R? With the I here, it's become Z. And the I with the B. This is the I with the B. The B is here. So it's become J. And T will become, let's put it down here. T is mapped with what? T is mapped with the R. So T with the R, where's the R? The R is down here. This is the R. Okay, so T will become K. And the last one is Y is mapped with I. Where's the Y? It mapped with the I. Where's the I? This is the I, and this is the Y, and the mapped letter G. So the encrypted it'll be A, F, T, C, Z, J, and then K and G. This is the encrypted using the keyword. Okay, remember that it's just mapping. All right. Remember this: if the keyword is less than the length of the plain text, you have to repeat it again. All right. So this is a very good way to do that. All right. Now these two examples are for substitution cipher. We have studied Caesar cipher, which is a very simple one using the shift, and Vigenere Cipher is more advanced form of Caesar cipher, which uses basically a matrix. A matrix. We use a matrix. This is a very simple way to do that. All right. Now, in the next part, we're gonna explain the transposition cipher.